Okay, Brim. Jumping for joy, huh? I know, I'm excited about a new video too. Okay, here we go. What's he doing now? I'm sure you're asking. We got all this stuff laying all over the table here. I've taken a bunch of the RC stuff out and have it strewn all about here. And what I'd like to do is show a few of my friends how to hook a motor up to a standard RC speed control. Ultimately, I think people are interested in these printer motors or motors that come out of tape drives or hard drives or computer stuff, and they want to run them like they would a normal DC motor, but of course they're mostly three-phase, so you need a speed control. And you've seen some of this stuff on my other videos where I've had the little servo controller and speed controller and motor on a stick. And so what I'd like to do is start with a few standard setups so that you can see the difference. Go from there. What I'll do is start off with the very simplest, and as I go up we'll go from the nitro motor to some standard electric motors, the brushless outrunners, and we'll look at how they hook up. Then we'll go on to how to hook up the speed control without using a transmitter and receiver stuff. After that we'll go on to something like the printer motor, and we'll get a little more complicated as we go up in the video. Maybe talk about some windings and magnets and so on. So let me get something set up and we'll start again. Okay, so here is a conventional nitro model airplane setup, and naturally we have the transmitter, and here's our receiver, standard receiver, and you can see the nomenclature there from top to bottom that says auxiliary 1, gear, rudder, elevator, aileron, throttle, and battery binder. I'm not going to explain what the binding is and everything else. That's sort of irrelevant to what's going on now. But anyhow, what we are most concerned about is this channel input here that says throttle, because that's where we're going to be switching things up a little bit and running an electric motor. Okay, so let's turn the transmitter on, and I'll turn the receiver on, and you see the receiver initializes, which means it's bound to the transmitter and nobody else can interfere with it. So now looking at the controls, here is a servo moving with the elevator control. Here is the aileron movement on the gimbal here, and over here we see two servos moving. Now there's two because there's an aileron on each side of the wing of the airplane. And if we go over to here, on this side, this is the rudder gimbal. So this one moving here would have the rudder and probably the steering of the nose wheel or tail wheel. Now our throttle. Here's our throttle control, up and down, and here's our throttle servo moving. Okay, so I've put up one of my real treasures here. This is a kit that I've had since about 1968, and we'll take a look at the installation. So I have a battery pack here. Happens to be lithium, not like the outdated one that I showed you. My receiver is in here, and of course here's our servos. So let me turn the switch on. Let's see if I don't know how I can do this with one hand on the camera, but let's have a whack at it. Alright, so the servos are on. I've got the transmitter underneath here, and you saw what the sticks do before, so what I'm going to show you here is the elevator servo. Alright, so you can see what's happening back here. Two push rods, someone's asking. I've got one on the top, one on the back with a separated elevator. That's for the advanced guys. Alright, so there's your elevator. The ailerons naturally aren't hooked up because I have the wing off. But here's the rudder. So you see our rudder going over here. Knife edge anywhere. And of course I mentioned that along with the rudder I have the steerable nose wheel. Okay, so we're interested in this throttle. So here's the throttle. Alright, you can see the linkage. I'm going to flip the plane over. Alright, so here's a look at this side up. And we want to look at this throttle linkage here. You can see now how that carburetor works. So we know all about what the servo does in the throttle position or the throttle channel on the receiver. And well, for those who wanted to know what this airplane is, this is called a Corsair Mark II. And of course that doesn't mean the Vought Corsair F4U like is made in our beloved Akron. This is the Corsair is known on the high seas. The sailing ships were Corsairs. And the wing, let's go over here and look at the wing. So because of that, there's skull and crossbones. And recently here when I reworked the airplane, I've made a decal here that is called the Black Pearl. So this is a plane that can, needless to say, really fly. The motor is pretty much oversized, typical for members of the Corsair Model Airplane Club. So it has a little control or indicator in here that gives the voltage of the batteries and so on, and the switches like we saw on the table. Alright, so much for that. We're going to go on to the next setup now. I'll turn this off and get on with it. Okay, so here we go with the electric motor setup. And you ready for that, Ram? He knows he's going to run when he sees the propeller going, so that's why he's heading for upstairs already. Okay, so anyhow, we know this is three-phase. It's a typical Outrunner model airplane. Well, it's not really typical, is it? Because you don't know what's going on with this, the looks of this rotor here. So, but I'm going to talk about that later. So, I hope if we have time. But anyhow, so it's three-phase. We've got 3 wires to hook up. These are little bullet connectors that unplug and plug back in. So with the three-phase, I don't know if you know this or not, but if your motor's running the wrong direction, you just take any 2 of these. It doesn't matter how they're hooked up. Take any 2 and reverse them and your motor will change direction. So we have the 3 wires then hooked up to a standard speed control. This happens to be a Castle Creation speed control, which is American made and probably one of the finest. I think this is 40 amp capability here. So we have the speed control motor hooked up. Now here's where things change. Our receiver is still over here, and I still have the servo plugged into the throttle control. So what I'm going to do is I'm going to unplug that servo that's in the throttle control of the receiver, and I'm going to plug in the speed control connection into the throttle. Let me do that and then we'll continue. Alright, so here's our connection from the speed control, and we're plugged into the throttle of the receiver, second up from the bottom. And here's our switch plugged in yet for the battery, but we don't need a battery anymore for that. So let's get that out of there. No battery switch. Instead, what happens here is when we plug the battery to run the motor in, there's a voltage regulator circuit in the speed control, which comes back into here and runs the receiver. Now, on these receivers, I think that anything you plug in anywhere with 5 volts or 6, or in this case, I think you can take a little more, in any of the channels, you'll power the receiver. So right now, we're going to run the servo, or run the speed control in place of the servo that was running the throttle on the motor. And at the same time, we're going to get our 5 volts back to the receiver here to run it. Alright, so let me get ready to plug that in and we'll have a whack at it. Okay, so I've jumped the gun on you just a little bit here and plugged the battery in. I'm using a small battery here. This is 1800 milliamp battery. 3 cells, LiPo. So it has a nominal voltage of 11.1 and will charge to about 12.6. Anyhow, the receiver is already initiated, and I left the servos plugged in here. Here's the throttle control, and now in place of the moving the throttle on the nitro motor, we're putting that signal into the speed control here, and we're running the electric motor. Okay, so that's pretty understandable, right? Okay, so much for that. Let's go on to the next step and look at the servo checker, or servo adjustment little device here, and we'll see how that can help us out. So hold on again. Need another set of arms. Okay, so here you can see the servos here are mounted on the outside of the fuselage, or in the fuselage, but facing out, which is a little bit different than the other plane. And of course you can see the ailerons work on this one now because the wing is on, and the rudder, along with underneath a steerable wheel on the back. So, alright, so now this one I have to be kind of careful with. I can wrap around and kind of hold it here when I do the throttle, because this would be a problem. But as you can see, so the speed control working on here. Alright, so that's quite powerful. And now we'll go on to something else. Okay, so getting on now with what's really important. Here is our servo adjuster, and this is really what the video is about. And I thought it was just necessary to show you how much stuff has to be going on before you can actually run a servo or the speed control. So you don't want to use all this stuff. You don't want a transmitter, you don't want a receiver, all the batteries and hookups, because maybe you don't even fly a model airplane. Maybe you just want to have a motor and run it, you know, because it's pretty desirable to be running a three-phase motor. So anyhow, the servo adjuster here takes place of all that equipment. And as I turn this, it's just as simple as that. Got a little battery pack going there, and you can make your adjustments to your airplane this way. So if I set this in the center, that's about what you would find when the gimbals on the transmitter are centered. And so you can see this is, you can't budge this now. So if your control surfaces are out of whack, you can make your adjustments and get everything all in alignment without having all this stuff turned on. So the servo adjusters, there's several different kinds. This one is about as simple as it can be. I've seen them from $4. I think this one was $9. And then some of them get kind of fancy, like this one that they call a Servo Lab. And I'll hook that up for a second. I think you've seen this in the other video, and a lot of people like this. So let me plug this guy in and we'll take a look at that. Okay, so here we are again. I've taken the speed control and I'm plugging it into one of the two servo connections on the servo adjuster. And now I think you understand. Battery is connected. You're going to ask, this is just a little voltage checker that plugs into the harness here, which checks each cell in the battery pack and then the total voltage. That way you can see if your battery is in balance and charged. Well, it's a little bit out of balance, but that's another story. So anyhow, now we've got the same thing going on here. So I can control the motor here instead of the servo. So I think with everything that we've looked at, you understand what's going on here. So now let's go on to something else. Okay, so you're saying I don't want to run a model airplane engine or motor. I want to run something else. So let's just hook something else up and take a look at it. Let's hook this guy up, and that'll be a little bit more fun and probably what we're actually getting to. I'm going to just skip this guy for another time. We'll put that aside and go into that some other time. Alright, so I'll hook this up and we'll have some fun. It's been a long time getting to this part of it, and this is what's most important. So here we have a motor from one of these office printers, and it's off the board. I happen to rewind this one, but it's three-phase. You can see, just like we've been looking at, 3 wires to hook up to the speed control. And of course we have the servo adjuster hooked up to it the way we've been looking at. For power, I've hooked up the power supply for now, but this could be anything. I mean, I can take this, plug it in here and hook this up to a 12-volt battery or whatever, you know. You don't need these RC connectors. You can just solder everything together. So here we are with our 3-phase motor. Oh, you're going to look at all this stuff sticking out the other side. Okay, so it's not a conventional wind. The 3-phase part of it is, but I have this other stuff hooked up in there, or wound in there, for doing some energy experiments, and of course that's another video. So let's hook this power supply up or get it going. As you can see that it's at 6 volts, and this power supply is only capable of a little bit over 3 amps, so we're not going to generate too many watts. So now we're ready to go. Let's see here. So there you have it. We're on our way. Now this isn't real smooth, I have a bad bearing in here, but that's up all the way. Now you have a way to run a motor without it being a model airplane and everything else. And this motor is not too bad. I think you can see there that it's got a little bit of power. You wouldn't have any chance whatsoever stopping it with the shaft. You'd skin your fingers up. So there you have full speed control right down to a stop. You lose your torque there, but giving it a little bit, it's not bad. So I don't know what else to say. I hope you made it this far. Everybody else is falling asleep already. There's my boy. We need to talk about these speed controls, how they're programmed by cards, how the windings are, how do you notice the three-phase. Here's a typical three-phase winding, one of mine. And if I can't get into it right now, I have to check the videos and see what kind of time we're running into, but if time's out, then I'll make another video and try to keep it a little shorter. Everybody's telling me my videos are too long anyhow. So, well, Todd was interested in seeing how this was done. I hope this helps, and I hope it helps for anybody else too. So if you have any questions, let me know. What I'm going to do is put some links under the video where the explanation is. And so look for that when the thing is posted, and I'll get to that as soon as I can. Alright, I just have to go on here and spend some more time on explaining what's going on. I know the video is already long, but here's one of these printer circuit boards with the motor on it. And like I mentioned before, these are from office printer and copy machines, and you can find them on eBay. Type in printer mains motor, printer mains motor, and that will probably get you to some of these. I mentioned that the connections for the three-phase will look pretty obvious on the board, and so here we have the three terminals that I selected here to try. And sure enough, the motor runs without me doing anything. So right now you can see that the motor is running pretty nice and smooth, huh? Okay, so the motor is running on that same setup that we looked at earlier with the servo adjuster running the speed control, and it's a fairly nice little motor. Alright, so there you have that. Now let's look at the magnet on one of these. Try to work this with one hand. Now I can't get it off. Hold on. Okay, so here's the magnet. This is the standard magnet that is in these motors on the rotor. That's the same thing that's going on there, smaller size. And they're a sort of a soft material. If you want to get them off, all you have to do is heat up the outside of the rotor and just peel these away with a screwdriver, and then you can put your other magnets on if you desire to do so. These magnets that come with it would be weak compared to neodymium magnets that you could put on as separate pieces. You saw this one running, and this is my rewind. And the rewind is in a typical three-phase setup. I have a drawing here that maybe I can go over with you just a little bit. So you can see the red, blue, and green are the three different phases. And the way this works out is I'll start here on on leg number 1. Wind it clockwise, skip over to 4 clockwise, 7 clockwise, 10 clockwise. So these are all 90 degree apart. Simply go to the next phase with another wire, wind 4, and then starting with 3, going to 5, 8, 11, all 90 degrees. Now you have 3 windings on your stator, and all of the 3 ends are over here, and they're tied together. And then your beginnings are where you hook your speed control up. So pretty simple, right? Now here's a stator that I wound for an airplane motor, and you can see the same thing. Here's my 3 phases, and here's where they're all terminated together. Now this is a little bit different in this respect. Take a look at the wiring. There's probably 14 strands of number, I don't know, I think it might be 28, wound all at one time. Now for the power of an airplane motor, these just happen to have only 3 windings per leg. So that's why they really crank up, and that's why they use a lot of current. Now let's look at the stator this is the stator that's actually in this machine over here. So it may be a little bit hard to see the individual wires, but I'll see if I can. Yeah, maybe there. So here's your 3 phases on the input, and somewhere over here there's a termination. Here's the termination of all the 3 phases, and this incidentally is a Y, or what they call a star configuration. There's another delta which has the end of one phase starting connected to the beginning of the next phase, and so on all the way around. And the characteristics change quite a bit with the way the motor runs and draws currents and RPMs and so on, but it's a whole nother story. All right, let's now look at the winding of the stator for using it with like an SSG circuit. So many people have asked, so let me go over that just a little bit. What I've done here is I have 2 of the legs wound for a trigger. They're connected in series. This one's wound clockwise, and then the wire is brought over to here, and this one is wound clockwise. Then the power phases are wound with a heavier wire, and the way that's done is it started here, wound counterclockwise, because these 2 are clockwise. This one is wound counterclockwise, then over to here clockwise, counterclockwise, over to here clockwise, counterclockwise over here, and then this is one is wound clockwise but different wire. So now over here we go counterclockwise again, clockwise, counterclockwise, clockwise, counterclockwise. So what you have then is every leg is wound in the opposite direction, and these 10 power coils are all in series all the way around to here. Then this one is skipped over, and you continue with the same wire till you get up to here. So now you have a standard bifilar configuration that you can plug into an SSG or possibly a half-wave Bedini-Cole circuit. Okay, what else do we have to talk about here? Something that we need to go over is the options on the speed controls. They are sensitive to how many windings and the inductance of the motor, so there's not 100% guarantee that everything's going to work out just fine for you. Some of the speed controls have options where you can program them in various ways. This is one way with a programming card. I'll show you that. So looky here. I've plugged this card into the speed control, and it gives you several options that you can select. There's a brake. That's actually used when you turn your throttle off of the on the transmitter. Your motor will almost go into an electronic brake, and this is used for two separate things. One, if you have a folding propeller on your airplane, it allows the propeller to fly back and up against the fuselage for like sailing. And also you can use it on a fixed prop to give your airplane sort of a stall in the air by braking the prop a little bit, causing some auto rotation, almost like a helicopter, to slow the plane down for a landing. This is going to take too long to go through all this. But anyhow, you have to select the battery type, cutoff type, which is whether your cutoff is sharp or slow, depending on the battery voltage going down, the cutoff voltages, and start mode, which makes your motor jump right on, or slow starts. And the timing is something that I wanted to get to. The timing does have something to do and works in conjunction with the inductance in the motor. These have a way of sensing what's going on. Some of it's completely automatic, and some of it you can get better running characteristics on your motor by what timing you select here, low, medium, or high. You can play some music when it starts. You pick how many LiPo cells for your automatic battery cutoff for low voltage, so you don't hurt anything. Governor mode, mostly for helicopters, and you make your selections down here. So that's one way of programming this stuff. Some of them are, like I said, you can just plug and play, and you're on your way, you know. The Castle Creations speed control is more sophisticated than some of them that you've seen running here, and they're computer programmed. You know, I was going to hook this up and show you, but it's just going to take hours and hours for me to go over everything here. You'll have to kind of look up some of this stuff yourself, look at some speed controls, and look at what they have to offer for the programming methods, and you know, do some research. That's what the internet is for. But anyhow, Castle Creations is a good choice if you do a search on that, or maybe I'll include the link under the video, and you know, have a look around. I'll include some links that help you understand the constructions and the operation of the motors a little bit better. The LRK TorqueMax Group on Yahoo is a great group for that. So the last thing I want to mention is that these motors, any of these three-phase motors, can also be a generator. Let me hook the scope up. Okay, so here's the scope is hooked up across one phase, and I'm just spinning it about this much. And you can see here on the scope that we're getting several volts. Scope's on the 1 volt scale, so I don't know what we're getting there. Maybe 3 volts, plus and minus. So you can hook this up right from the get-go with a three-phase diode bridge and turn it into a little generator. What I wanted to tell you about these motors, though, is that they all draw a little bit of current, more than what you would expect. They even have a current draw when they're sitting idle, naturally, because the speed control has to use some potential off your batteries. So there's a lot of things you really have to know about these charts when you're building motors. You notice this happened to be 8 magnets around, which is basically the same thing as what you have in one of these stators when they are taken apart, the stator motor, and see this full ring. There's actually 8 different poles in here as it goes around. Now, Alright, so what else can you do? 8 is not the only option. You can also use 16 magnets around and still have this same wind here with all the legs wound in the same direction. 14 though happens to be the most popular, and for 14 you have an altogether different wind. The legs are not wound all the same direction. So if you go to this site that I'm giving you for these charts, and you install the number of legs on your stator and how many magnets you have, you will come up with a different configuration. Also, this magnet here isn't the only option. If you want more strength, you can install magnets like this. 12 naturally if you're doing an SG sort of a setup, and then 8, 14 or 16 if you're doing a 3-phase motor, and you can get some pretty good strength with these. I have magnets on the outside of this if you're wondering, and the idea was to run the stator motor normal on the inside and generate some current on the outside with outside coils. How did it work? I can't even remember if I tried it, but maybe I'll get back to that someday. So at least I tried to get you started. For those of you who've bought these motors already or have had the questions, I hope this helps answer them. And well, you know, that's it. Wish you guys a good day, and take it easy, and we'll do another video soon. Take care. Okay, Remy. I don't think you can expect Michael Flatley to be knocking at your door anytime too soon. Keep practicing.